friends, welcome to our channel. So in this video, we are going to look at today's daily challenge problem, water bottles 2. So again, we are going to solve this problem using the plain while loop. So this problem is actually a slightly modified version of water bottles 1. So here, the operations is the following. So you can perform one of the following operations. First, you can drink any number of full water bottles, turning them into empty bottles. Or you can exchange this number of empty bottles with one full water bottle, and then you increase the number of exchange by 1. You can understand this one as the price you pay to get a full bottle of water, right? So the price is increasing. So this is the one thing. Another thing to notice is that you cannot exchange multiple batches of empty bottles for the same value of a non-exchange rate. So we want to return the maximum number of water bottles we can drink. So here there are 2 examples with detailed explanation, right? So for example, here you have 13 full bottles, and then you need originally 6 empty bottles to make a full bottle. So the strategy will be the following. You first, because you currently have no empty bottles, you cannot do exchange, right? You just drink all of the bottles. So now the empty bottle is 13. And then, because you don't do exchange, the exchange remains the same. So the number of bottles drunk is 13. And then, because you do not have full bottles, you can only do exchange using 6 empty bottles to get one full bottle. So after this, you get 13 minus 6 is 7. You get 7 empty ones, but the number exchange is also increased by 1. So this is the current state. So the number of bottles you drink is still 13. So now you can do the exchange, or you can first drink. But here, you need to first do the exchange. So because afterwards, you will get less bottles. So overall, as we write here, at any time, as long as we can, so we can do the exchange, right? First, using the current status of number exchange. So once you do this exchange, you get 2 bottles, and then the number exchange is increased by 1. So at this time, you still drink the originally 13 bottles. Now you have 2 bottles. You drink up, you get 2 empty one, but 2 is less than it. You cannot continue. So you get 15 is the overall. So similarly, you can analyze example 2. For example, here you can also consider first drink this one. So from 13 you get 14 drinked. Then the number of bottles is 8, still 8. Then you can exchange for 1 full bottle, then drink it, right? So this is also a possibility. But overall, as long as you first do exchange, it always gives you the maximum bottles of water you can drink. So that's the main idea. So though the logic is slightly indirect than the first version, but here I feel that the logic is still rather straightforward. So in order to better understand, so we can first write it in a Python code, and then we can do it just translate the Python code into C# code. So first so I did some change. So this is the number of full bottles originally. This is the price you pay to exchange from empty bottles to 1 full bottle. So we can initialize the result variable. So this is the integer, right? So its final state is what we want to return. And then the number of empty bottles at the very beginning is also 0. So because this result and empty are both immutable, therefore you can write this way, this is the one way. Or you can write like this, set result equals n empty equals 0. It's also legitimate. Then we are going to write a while loop. Well, first n bottles is greater than 0, or the n empty is greater than or equal to the current status of n change. Then you can do. So first I want to check if n empty is greater than or equal to n change, right? If this is the case, we first do exchange. Therefore, in this case, the number of bottles is incremented by 1. And the number of empty, so it means n empty, so is decremented by this n, the current status of n change. Then later the n change is incremented by 1. So this is the first priority. Otherwise, then what do we do? So we drink all the bottles. So the result is incremented by the current number of full bottles, right? And then the number empty is also increased by this n bottles. And then after those, we set n bottles to be 0. But in this case, we don't need to increment this n change, right? So this is the code. Then we just need to return the result status, right? So actually what we did is just translate this statement into code format. So within this while loop, we have a if and else inside. Let me run it. It passes the two test cases. So now let's look at the generic case. Yeah, it passes all the cases. So well, this is the one. Now let me copy this code here. So I'm going to write a version with C#. So here I just let me retype that to explain to you what's going on here. So here first we want to do this is the Python code, right? So let me initialize the result variable, which is a integer, right? So let me so it's an int, so result, so I'm going to set to be 0. And then also initialize the empty, so n empty to be 0. And then we get a while loop, right? So while, so the condition is n bottles is greater than 0, or, right? So n empty is greater than or equal to n change, right? So if this is the case, so what we are going to do is to do the check. If n empty is greater than or equal to n change, so what we are going to do is, so first we n bottles increase this by 1, meaning that I use this number of empty bottles to get a full bottle, one full bottle. And then the n empty is decremented by this n change. So then I update the n change status. So n change is increased by 1. Or you can write like this, right? But let me write like this. So this is the if clause. Otherwise, so what we are going to do is, so we do result is increased by n bottles, right? So this one. And then the n empty is incremented by n bottles. So similarly, we set n bottles to be 0. And finally, after we exit this while loop, we just need to return the result variable. So this is the C# code. Let me first check the two test cases. Yeah, it passes the two test cases. Now let's look at the generic case. Yeah, it passes all the cases. So I would say that's basically about it for the current video. Thank you for watching.